Hello, my name is Jade McGinty, and today I will be talking to you about the arithmetic sequence. Now, first you need to know an arithmetic sequence is any sequence of numbers that increase by the same interval. So in our example, 7, 10, 13, 16, 19, 22, 25, and x are an arithmetic sequence increasing by 3, the first, second, third, fourth, fifth, sixth, seventh, and nth going on. So my goal today is to teach you how to use the equations associated with the arithmetic sequences. The two equations that there are is the equation to find the nth number, which is a of n equals a of 1 plus n minus 1 times d, and the nth number is any number inside the arithmetic sequence that you want to find based on its numerical position. The other the other equation to find the sum up to the nth number is s of n equals n times a of 1 plus a of n divided by 2. Now, none of these equations mean anything to you if you don't know what the variables within them mean, and so I will teach you how to use those next. A of n, which is in the first equation, is the value of the nth number of a sequence. A of 1 is the first value of a sequence. N is the numerical position of the sequence. D of a number in the sequence. D, the common difference, which in our example is 3. And S of n is the sum up to the nth number. Now, to more properly show how to use these arithmetic equations, I will now do a few problems from your math notebook, 5 to be exact. The first one is actually the first equation or problem in this section, which is 10 of 1. So, to sum it up real quick, Angela is born, and Uncle Zachary wants to put money into her college fund. When she's born on the first month, he puts in $50, and then he slowly increases the amount he puts in by 3 every single month. And so the first part of the question, A, is asking us to write out every month how much money he'd put in. So we start off with 50, and then we go to 53, then to 56, then to 59, then to 62, then to 65, then to 68, then to 71, then to 74, then to 77, then to 80, then to 83. We're going to make sure that these are all numbered right. This is the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, and 12th. There we go. That is the amount of money he deposits on the 12th month. Now, the second part of the question asks us to write an equation and test it against itself, and then use it to find the amount of money he deposits on the last month of her 18th birthday, of her 18th year. So, what we would like to do is I would like to show that this equation that I showed you here is exactly what we mean. So we have a of n equals the first number of the sequence, that's a of 1. The first number is 50, so we do 50 plus n minus 1 times the common difference, which is in this case 3. Now we test it against itself. We have 1 minus 1 is 0 times 3 equals 0 plus 50 equals 50, which is our first sequence. So there we go, first number of the sequence. Now we need to test it against 18 years, the 12 months of her 18th year, which means I need my calculator to multiply out what 12 times 18 is on 12 times 18, that is 216. So our n number will be 216. So a of 216 equals 50 plus 216 minus 1 times 3. So what we have now to do is a 216 equals 50 plus 215 times 3. And now multiply it on the calculator. 215 times 3, 645. So we have 50 plus 645 equals 695. Here, let me rewrite that. 695, and that is the amount of money he deposits on the last year of the last month of her 18th year. There we go. Moving on to the next question, which is 10 of 2, actually. So this question is much like the last one. Angela continued to think about Uncle Zachary's savings. Uncle Zachary wrote his equation as t of n equals 3 times n minus 1 plus 50. Verify that this equation is the equivalent to the equation your team wrote for the problem 10 of 1 and represents the same sequence. What is the advantage of writing the equation as Angela did? What is the advantage of writing it as Uncle Zachary did? So this is actually that equation is t of n equals 50 plus n minus 1 times 3. That's exactly how we did it. Exactly. Now it asks for the advantage of doing it like this. You can just find any number you want in the sequence, any nth number in the sequence. You can find 150, the 1000th number in the sequence. It's very, very easy. It's very, very quick and to the point without having to count it out like we did here. So, moving on to the next part of the question. B. Determine the amount of money in Angela's college fund at the time of her first birthday, after Uncle Zachary had made exactly 12 deposits. This is super simple. We just have to use the sum equation that I showed you here. So this means we just need to go S of n equals n a of 1 plus a of n divided by 2. And so we just plug in for the variables. So we're going 12th month, so S of 12 equals 12 times 50 plus, and we already know what the value of the 12th month is because we wrote it out up here, 83 divided by 2. So what's 50 plus 83? That is 133, I believe, but we can just put it out right over here. So that would be 3, 2, or 5, 3, yep, 133. So 12 times 133 divided by 2, but we can just cross those out until it's 6 times 133. Put that into our calculator, which is 798. So the sum in our account at 12 months is equal to $798. Simple, easy, to the point. C. Angela wonders how much money had been saved by her 5th birthday. Can you think of ways you might be able to figure this out without having to add the amounts for each month? And then it goes on to say we don't have to do it. That is exactly what we're doing here. So we just did the quick and easy way of getting that sum without having to write it all out and add it up, and it added all up. Very simple. It's just S of n equals n a of 1 plus a of n divided by 2. Very, very simple. Okay, moving on to the next question. 10 of 7, I believe. 10 of 7 goes a little like this. There are 300 people visiting a fair. Well, okay, I'll just read it. The 300 people who are lined up outside an amusement park all enter by 8:15 a.m. By 8:30, 550 more people enter, and after 8:30, every 15 minutes, the number of people who enter increases steadily by 250. All of the people are planning to stay for the parade at noon. So this is actually just an arithmetic sequence in disguise. What you have here is arithmetic sequence increasing by 15, not the sequence, sorry. The arithmetic sequence is increasing by 250, and an interval is every 15 minutes. So 1 would be 300, but after 300, 550 more people enter, but that's at the second interval 15 minutes later, which is at 550, and so on and so forth. So the first part of the question asks, how many people enter between 11:45 and noon just in time for the big parade? So first, we need to find out what the nth number of noon would be. How many 15-minute intervals are in an hour? So we have 60 divided by 15, which we all know is 4. So 4, and then we have 4 hours because 8 to 12 is 4 hours. So we have 4 times 4, which equals 16. So we're looking for the 16th number. So that means we're looking for a of 16 equals the first number, which is 300, plus 16, not 15, 16 minus 1 times 250. That's going to be a big number. So now we just simply have to plug in all our stuff for equations. So we got 300 plus 15 times 250. Now we multiply 250, so 15 times 250, 3,750. So we have 3,750 plus 300. That is 4,050. So what we figured out here is at the 16th increment, which is at 11:45 to 12, 4,500 people will enter, and that is the A. But there is a second part of the question, B. Represent the problem as a sequence and write a formula for the nth number. So we've already done that. Very simply, the problem is a sequence, so we've already done that here. Now we just need to write the formula for the nth number, which is a of n equals 300 plus n minus 1 times 250. Good. Done. Moving on to 10 of 8. I'm going to use a new sheet of paper for this. 10 of 8. So this question, also very simple, asks, what if Uncle Zachary, from problem 10 of 1, had increased the amount he was saving for Angela by $5 each month instead of $3? So how much would Uncle Zachary have deposited on Angela's second birthday? So this question is very simple because it's just changing the difference. So our question remains a of n equals, and this is a of n equals 50 plus n minus 1, but now 3 is instead 5. Okay? So the first question, how much would Uncle Zachary have deposited on Angela's account on her second birthday? That's just 24 months, so we just plug everything in. It's very simple at this point. A of 24 equals 50 plus n, or 24, excuse me, minus 1 times 5. So you have 50 plus 23 times 5. Plug that into our calculator. 23 times 5, 115. 115 plus 50 is 165. And so on her 24th month, he would have deposited $165. Sweet, right? So, second part of the question, write a formula for the nth term of the sequence for this situation. We've done this already, but we can write it out once more. So we have a of n equals 50 plus n minus 1 times 5. This is the nth number of the sequence, and this is how we do it because this is now a common difference because now he's doing 50, 55, 60, so on and so forth. Now, final question, C of this question. How much money would have been in the account on Angela's first birthday just after Uncle Zachary made his 12th deposit? So this, we use our sum equation again, which I will remind you, S of n equals n times a of 1 plus a of n divided by 2. So now this isn't much different. We just have to plug everything in and remember that 5 was a common difference. So we have S of 12 equals 12 times a of 1, which is still 50, plus, this is where it gets tricky. We don't know what a of n is anymore because it increased by 5. So what we have to do is just plug 12 into the first equation. So we have a of 12 equals 50 plus 12 minus 1 times 5, which is 11 times 5, or not 50, excuse me, 11 times 5, which I think is 55, yeah. 55 plus 50 is 105, so what we have up here is 105 divided by 2. So 12 times 50 plus 105 is actually, that would be 155. And 12 can be divided by 2 by that thing, by the denominator, which is 2. So we have 6 times 155 to figure out how much money she'll have in her account on her 12th month. So that would be 155 times 6. She has $930 in her account on her 12th month. Sweet. Moving on to the final question, which is 10 of 10. This question asks, write a formula for the nth term of each of the following series. So now we just need to find out the nth term of each of the following series, which is going to be very simple because we can just write out the formula and just show what we know. So first, the series goes 3 plus 10 plus 17 plus ... So first we must identify how much this is increasing by. 10 minus 3 is 7. 17 minus 10 is 7. So we know that the common difference here is 7, and we know the first number is 3. So what is our equation? It would be a of n, first number, 3, plus n, whatever n we want, n minus 1, and the common difference, 7. Sweet. Done. Next one, the final question I have, is 20 plus 11 plus 2 plus ... So, what is 11 minus 20? in this case, this is going to be negative 9. And what is 11 to 2? That is also negative 9. So right here we have our d. What is the first term? That is 20. So we have a of n equals 20, because that's our first term, plus n minus 1 times negative 9. And there we go. There it is. That is how you use the arithmetic sequence and its equations. Thank you very much.